In 2.2, we're going to look at product and quotient rules, and then we're going to take it up into that next step of higher order. So first I want to start with the product rule, and this is the product of two or more functions. Now we saw with the sum and difference rule that you would just do each individual term. With this one, what you're going to do is you're going to address each derivative and carry other things along, plus another derivative and carry things along. So you're going to hear me say this quite a bit. But when you're working with f of x times g of x, what you're going to do is you're going to do derivative of the first times the second plus the first times the derivative of the second. So you can see by the coloring that the red were your derivatives, but you can see how the blues stay consistently. So first we addressed f prime of x, carried everything along, plus f of x, now take the derivative g prime of x. So f of x is now going along for the ride, and g of x gets to be in the spotlight and do its derivative. So you're going to take each piece derivatives at a time, carry everything out, and then add up those pieces from there. You do not do it in one full swoop, derivative of everything you see. So be careful as you go. So let's jump into some problems here, and I think with the examples you can start to kind of see what's going on with it. And so in this first one, I'm going to take h prime of x is going to be equal to, so I'm going to take the derivative first of this function here, 3x minus 2x squared. And so that derivative would be 3 minus 4x. Then carry along the rest of the problem, 5 plus 4x. Plus, now write your first part, 3x minus 2x squared. Now it's time to take the derivative of the next piece, which was just 4. So again, I'm keeping with my same color-coded system here, so you can see the pieces that are being taken derivative of and the pieces that are remaining the same. Now, this is my raw derivative. This is product rule. From here, I have to clean it up and use my algebra. And so I'm just going to write in blue just for the cleanup. So h prime of x is equal to, I'm going to FOIL this part out. So this gives me 15 plus 12x minus 20x minus 16x squared, plus distribute the 4 in here. So 12x minus 8x squared. I'm just doing algebra. Now let's combine like terms. So this gives me, putting my x squareds together, that would be negative 24x squared, negative 20, positive 12, so it would be minus 8x. And looks like I forgot this one. So let me modify that. So that would give me plus 4x. And then our last plus 15. So you can see, although we had to do product rule and we got our first raw derivative here, we had to do our algebra and clean it up. And the whole reason we want to clean it up from there is if we were to take another derivative again, like we saw in the last lecture of the second or third or fourth derivative, this would be more user-friendly to use this as our first derivative, and then we could look at the second derivative very quickly. Other applications, if we're looking at tangent at a point, I would much rather plug into that quadratic than plug into this string of terms up here in our raw derivative. So make sure, although you can execute the calculus, you clean it up with the algebra accurately. Let's do another one, and let's do one that has that sine function in it. So again, I'm going to do it and use my same colors, and so I'm going to find y prime, and that's going to be equal to, first we're going to do derivative of 3x squared. So that derivative would be 6x times, carry along that sine x, plus, we're going to bring down the 3x squared, times the derivative of sine x, which is cosine x. Remember, you just need to commit those to memory. Once you take your raw derivative, then clean it up however you can. And really for this one, there's not much cleanup you can do. I could just write 6x sine x because those parentheses are not changing anything, plus 3x squared cosine x. And that would be my answer. Let's do another example. So example number 3, as we scroll down here, it says 2x cosine x minus 2 sine x. So you can see this is going to be a combination of rules. If we look at this first piece here, this is going to involve our product rule because it has two functions going on in this. It has the 2x and then it has the cosine x. Then minus the 2 sine x, we can just treat individually. So be careful with this. So this would be y prime is equal to the derivative of 2x, which is 2. That's better. Times cosine x plus 2x times the derivative of cosine x, which is negative sine x. I'm going to stick that negative in front of that 2x so I don't accidentally think this is subtraction. And this entire piece here is that product rule. Continuing to the next piece, the derivative of negative 2 sine x is negative 2. The derivative, the negative 2 is your constant going along for the ride. The derivative of sine x is cosine x. Whew. So that is my raw derivative. I'm going to clean it up. First thing I'm just going to do is I'm just going to write y prime is equal to what I have, a 2 cosine x minus 2x sine x minus 2 cosine x. And you can see that I have a 2 cosine x and a negative 2 cosine x, so those will cancel with each other. So I'm left with negative 2x sine x as a result. So again, just be careful with your basics. Majority of students get that raw derivative, but they struggle on the cleanup, and you do need to complete the problem. So product rule, you take the derivatives, derivative of the first times the second plus the first times the derivative of the second, your basic rule. This leads us into our quotient rule. Now, here's the reason I emphasize that product rule, because quotient rule, what we're going to do is we're going to do the same thing as what we did with our f's and g's like you saw in product rule, but now we're going to subtract them, and then we're going to divide by g of x squared. So the derivative quotient rule is f of x over g of x is equal to derivative of the first times the second minus the top times the derivative of the bottom all over the bottom squared. Let me say it again. It's the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. So you can see within this problem, here is a piece that's a derivative, here is a piece that's derivative, the other pieces are coming from the original function. So go slow and walk through your steps. So let's do, I think, just jumping into an example here. So this would be y prime is equal to, you're going to do the derivative of the top, which is 5, times the bottom, x squared minus 1, minus the top, 5x minus 2, times the derivative of the bottom, 2x, all over the bottom squared. That's my derivative, but I got to clean it up now. So this gives me y prime equal to, so I'm going to distribute the 5 in here, so that's 5x squared minus 5. I'm going to distribute the 2x into here, and I'm also going to distribute that negative. So that gives me minus 10x squared plus 4x all over. Now this bottom, I am not going to FOIL out the bottom. We saw this in earlier sections when we're working with numerators and denominators. A lot of times you're going to see that denominator just left alone because there might be some cancellation properties you can see by looking at the pieces versus FOILed out. So now I'm going to clean up the top. So I've got a 5x squared and a negative 10x squared, so that gives me negative 5x squared plus 4x minus 5 all over x squared minus 1 squared. And then that is my derivative. So the struggle with quotient rule is, one, making sure your pieces are correct, but again, sound like a broken record, it's going to be the cleanup of that problem. Let's continue on with our examples. This one says f of x is equal to 3 minus 1 over x divided by x plus 5. And I want to find the derivative of it. Now I'm going to tell you I'm going to do a little bit of algebra here first. Since this has a fraction, and let me go ahead and write this a little bit larger horizontally here. So this is equal to, we've got an x plus 5 on bottom. On top, we've got 3 minus 1 over x. So we have a fraction within a fraction. So what I'm going to do first is I want to clean this up a little bit, and I'm going to multiply by a fancy 1 over here. And I think if I multiply in the top by x and the bottom by x, first of all, that's a 1. It's not going to change the value of it. But 2, what it's going to do is it's going to remove this x of a fraction here. So I have a better overall numerator and denominator to work with. And so let's come down here and multiply that. So that gives me f of x is equal to, distribute that x in there. Okay, it gives me 3x, no big deal. But these x's will cancel with each other to give me a minus 1. All over x times x plus 5. And because we're going to have to take the derivative in just a minute, I am going to go ahead and call that x squared plus 5x so that I don't have to do a product rule within that denominator with my quotient rule. So that's my new function. And so applying a little bit of algebra was really beneficial to me. Let's now do our derivative. So that says f prime of x is equal to the derivative of the top, which is 3, times the bottom, x squared plus 5x, minus the top, 3x minus 1, times the derivative of the bottom, which is 2x plus 5. All over, don't forget your denominator, the bottom squared. Now, clean it up. So distribute your 3 in here. So this gives me f prime of x is equal to 3x squared plus 15x. We're going to have to FOIL this out and then distribute that negative. So I'm going to go ahead and move this negative, distribute it throughout here so I can then just FOIL. So that gives me, let's see, minus 6x squared plus 2x minus 15x plus 5. And then I'm going to divide that whole thing by x squared plus 5x squared. I'm going to combine those like terms together. So let's see, we have a 3x squared and a negative 6x squared. So it gives me negative 3x squared. We have a 15x and a 15x, so those will cancel each other. And I'll just be left with this 2x, so plus 2x. And then plus 5 all over x squared plus 5x squared. And then that would be your derivative. And so once you understand the quotient rule and how to create those pieces, the biggest stumbling thing is going to be your algebra, that multiplying through and getting rid of the fraction, and then also just your cleanup, making sure you don't make small errors along the way. Let's do this next one, number 3. So it says y is equal to x squared plus 3x all over 6. And so I'm going to manipulate this one a little bit before I jump into the derivative. So this would be equal to 1/6 times the grouping x squared plus 3x, because multiplying by a 1/6 is the same as dividing everything by 6. And based off one of our constant rules that we saw earlier, we know that that 1/6 can just go along for the ride. So I'm going to say y prime is equal to, I'm going to leave that 1/6 alone. The derivative of x squared is 2x. The derivative of 3x is 3. And so I have my derivative, and then I can put it back in the format that it started in. 2x over 3 plus 3 over 6. And so don't be alarmed with certain fractions. Just remember what can you do with them, and maybe do some algebra before you get started. A couple more examples to finish up this lecture. Let's look at this number 5. We're going to say 4 for a later lecture. When you're looking at this problem here, Let's do a little bit of cleanup before we get going. First thing I notice is this -3 and 7, that's just kind of like my constant. I'm going to pull that out front. So y is equal to -3/7, and then we have 3x minus 2x squared, all divided by x. But when I get here, I notice that there's quite a bit of similarities there, and I can actually clean this up a little bit more so that maybe I don't always have to execute a quotient rule, because I could do my algebra first. I notice that in the top portion of this grouping, I could factor an x out, so it gives me 3 minus 2x all over x. And once I'm able to factor that x, I can cancel it. So my new function would be -3/7 times 3 minus 2x. And that's a lot easier to handle in terms of derivatives, because then your derivative would be -3/7 is going to go along for the ride. The derivative of 3 is just 0, so I don't need to write that. And the derivative of -2x is -2. Clean this up, put that over 1, multiply across your tops, you get 6, over multiply across the bottoms, which gives you 7. And that is a surprising answer compared to what we began with. So don't be afraid to do your algebra before your calculus, because it could really help you out. Whereas if you had not, right here, you had been looking at quotient rule and you would have still gotten the same answer. It would just maybe been a little bit more of a difficult path. The last thing I want to end with here is looking at our remaining trig functions. We have looked at sine and cosine, and let's pick up our remaining trig functions. So your first one is going to be when you're taking the derivative with respect to x of tangent x, its derivative is secant squared x, and that is just a fact that we are going to accept and commit to memory and use as we move through some of these rules. The next one is the derivative with respect to x of cotangent x, and that's derivative is negative cosecant squared. So you can see between these two functions, they both have a squared, they both have the reciprocal function of sine and cosine, and one just has a negative. Similar pattern to we saw with the sine and cosine, similarities, but one had a negative. Looking at the next two, we have derivative with respect to x of secant x, and that's equal to secant tangent, and the derivative of cosecant is equal to negative cosecant cotangent. So again, you can see its derivative is a product of two of the trig functions, and one of them has a negative. So I just kind of relate those together to help me to remember them. So now we have all 6 trig functions. We've got our product rule, we've got quotient rule, we've got our sum and difference rule. So we've got quite a tool bag of rules that we can use to work with these different functions we're going to encounter.